Hello everyone, today we are going to record a video to explain the AMT TCU. Shifting strategy. The simulink simulation model. First, let's take a look at the architecture of the entire model. It is a mathematical model. It mainly consists of mathematical formulas and calculations. Let's first look at the drive and braking system. This system is based on the actual vehicle speed and the required speed. The required speed is imported through our working conditions. Imported. There will be a difference between them. Based on this difference, to determine whether it needs to accelerate or deceleration. If it's deceleration, it's automatic. The signal here is our actual speed. Finally, we need to obtain the current required torque of the motor. If it's less than 0, it is a brake pedal travel. The final result multiplied by the maximum braking force set by humans to get the current braking torque of the vehicle. In the same way, you can also get the current acceleration of the vehicle. The stroke is the required torque. Let's click on this module. Let's take a look. The models and calculations inside. We have added some oscilloscope and selection modules. This is the accelerator pedal, right? This is the automatic pedal. There are results output here. Next, let's look at the motor and transmission system. This module is based on the motor demand torque transmitted by TCU. The gearbox's transmission ratio, and the wheel speed as inputs. And calculates the actual output torque of the gearbox, the maximum output torque of the motor, the current speed of the motor and the actual output torque. Let's take a look at the internal of the module. I wrote a Word document about the module's internal. For a detailed explanation, I explain the formulas and calculations. Next, let's look at the vehicle system. This module takes the actual output torque of the gearbox, the automatic torque of the vehicle and slope as inputs. To calculate the driving resistance of the vehicle. Mileage, speed, or speed. Acceleration and other real-time information of the vehicle. It includes slope resistance and rolling resistance. Of course, it is still a calculation formula. Next, let's look at the strategy of shifting to second gear. This system mainly uses the motor's demand for driving torque. Driving torque and the current speed of the motor as inputs, and after a series of internal calculations, output the state and time of gear shifting. The most important is the current gear ratio. First, according to the motor's required torque, current speed, the current gear ratio, and whether the shift is completed. The state is input. The shift command is obtained through calculation code. Motor demand torque and gear shifting status. Here are some flowcharts, including the flowchart of the entire system and some instructions. Next, we run this anti-pin to see the results of each parameter. This is our working condition. Of course, I have already run the simulation. Next, let's look at the actual speed of the motor. Next, let's look at the gear ratio of the shift. The shifting time. Next, we will check these results one by one. This is the acceleration of the motor. The driving of the car. This is the stroke. This is the stroke. This is our resistance. Let's look at the speed of the wheel. Good. This is the running state of the entire model. In simulink, process. Next, let's take a closer look at the composition of each part. This is a pig controller. This is the state of our motor. Let's take a look at some codes, the description and function of the code. Okay, thank you for watching. See you next time.